Hello all, here to talk about the Chrysler charging system on classic Mopars, Chryslers. Actually pretty much everything Chrysler built since 1960 through mid-70s or so, late 70s. This is the basic layout. Pictured here, or actually diagrammed here, is 1970 and up, with the ignition switch mounted into the steering column, the Molex connector at the bottom of the column, electronic voltage regulator, a dual isolated field alternator. The subject today does not involve the regulation of the alternator, so subsequent slides here will not show that circuit. But this is a basic layout. No activity at all going on, no current flowing. Assuming a fully charged battery, shouldn't be any current flowing anywhere. Turning on accessories, key or accessories. We'll get some current flowing, and from the factory as originally designed. And I should say it again, this is not about any modified Chrysler charging system, any ammeter bypassed charging system, any engine compartment bypassed charging system, or any other vehicle, anything. 99% of the other vehicles on the road are not a part of this conversation, and this is only the original Chrysler charging system with a functional ammeter as originally designed. Loads on, key off, engine not running, the battery is the primary voltage potential device. All power will be sourced from the battery, and this indicates the current flow to your factory loads without the engine running. Cross the ammeter through the bulkhead terminals in cavity 16 typically. That can vary a little bit from model to model, but for most cases, B&E bodies, it's cavity 16 on that battery feed. It's a red wire typically, about 12 gauge originally. On the other side of the ammeter is a black wire. Black wire runs to splice 1. This is taped up inside of your dash harness. It's referred to as a welded splice. From there, another 12 gauge wire goes back to the bulkhead connector, back out to the alternator output stud. But in this case, the flow of your loads, your factory loads, while the car is not running, is through splice 1 and through these other feeds to the fuse box, headlight switch, ignition switch, and then off to your loads from there. Ammeter will show a discharge. It'll be an estimation. It's not a real accurate measurement, but it's a discharge, and it tells you which direction the current is flowing. It's discharging the battery. The battery is providing this power. Let's start it up. Get the alternator functioning. Alternator now has sufficient RPM. It is also supplied with field current from the ignition switch now that the key's been released. Alternator is functioning. Should be operating in 13.5-14 volt range. That is higher than 12.6 from the battery. That makes the alternator the primary power source while the engine is running. This device provides the current flow to make these accessories and factory loads operational, not the battery. And you'll see that this does not involve the ammeter. So the ammeter should show almost zero. Any current flowing through the ammeter under these conditions is battery charging current. If you just started the car, there'll be a bump in charging for the first few minutes after the car's been started to replenish whatever it took to crank the thing over. Once the battery establishes full state of charge, there's very little to no current flowing in this direction on this side of this wire through that bulkhead connector to the battery. The needle will show 0 under normal operating conditions. Everything healthy. Everything's functioning the way it should. The alternator is providing all the current that the accessories and feeds and factory loads, lights, wipers, fans, whatever you got turned on. If the alternator is keeping up with it, there will be no current across this ammeter. Little to no current, only charging. Should the alternator not provide enough current to cover these loads, then it will start pulling stuff from the battery. Voltage will drop below the 12.6 of the battery, and then the battery starts adding in some of this current. Then you will see discharge current as this flow of current reverses and comes back and helps to provide power to splice 1. But if the alternator is keeping up with the loads, ammeter should be zeroed. That is the original design of the Chrysler charging system from that time. Almost every passenger car had this from 1960 and up. Vans and trucks had something very similar to this with very little modification. The ammeter is in the dash to monitor your charge-discharge current status of the battery. It's not there to monitor current loads. There is no current flowing. None of these load currents are flowing through here unless the alternator is not functional. And then we go back to this other slide. If the alternator can't keep up with it, then you're going to be pulling some current from the battery. There will be a discharge indication. You better find out why that is. Something happened to the charging system, alternators failed, regulator failed. If you're driving around and it's showing a discharge, something needs to be looked at. Okay, to the subject at hand, loading, adding things, adding loads, adding fans, adding lights, powering up accessories you've added to this particular system. What is the impact? There are some who believe there is no impact, but there most definitely is an impact. Pretty simple, basic electrical theory here. In this example, we're talking a 15 amp cooling fan. Maybe you've had an electric cooling fan. Actually, most of those fans pull more than 15, but for this example, let's just say you put a 15 amp load here. And you've connected it straight up to your battery, and you've done no other modification to your charging system. When you start that car up, that power is going to attempt to come from the alternator, not the battery. You have added that 15 amps to this charge output wire, as well as the factory current still has to be there. You're still running your factory loads. You've now come down to this first charge circuit Packard connector on the alternator feed. You've now doubled your current across that, at least, to splice 1. From splice 1, because the alternator is the power source, to get to that load, it's got to go through the ammeter and up to the return feed. Another set of Packard connectors in the bulkhead connector. Those Packard connectors are not designed for any kind of current. They've been a problem since these cars were new, but when they get excessive current through them, there's resistance there, and they get heat. They can get hot, and you're going to melt things. Very common. Back through your connection to the battery, back to your load. So you've placed that 15 amp load across this entire system, and it's not designed for that. It's only supposed to register charge current or discharge current from the battery. We're now showing a charge on the ammeter. It's not really charging. It's 15 amps worth of your load stuff coming through the ammeter. The purpose of the ammeter to monitor actual charging is now defeated. It means nothing. You're going to drive around whenever that load's on, whenever that fan kicks on, whenever you turn on those headlights. You got headlights wired to your battery. You're going to see that current on the ammeter as a charge current, as well as your current stressing the entire ammeter and the connections that are on the back of it. So how do we add loads in without affecting the charging system? You connect those loads to the alternator or somewhere on the alternator side of the ammeter. It can be anywhere along this wire, it can be under the dash from the bulkhead connector to splice 1, anywhere from splice 1. Just like all the factory loads are getting all their connections on the alternator side of the ammeter, your added load needs to be there as well if you do not want to impact the existing circuit. Again, in this example, we're pulling 15 amps off of this while it's running. As long as the alternator can provide that 15 amps and whatever the car needs, there will be no current across here other than the charging, the trickle charge current from the battery taking place, assuming the battery is fully charged. Ammeter normally will show 0. Nothing is moving. If there is something moving, it's very little, not enough to make the ammeter move. Sometimes you can just barely perceive there's a charge current. If on the other hand there's a problem in the battery, or it's low, the charge is low, you're going to see charging current here. And again, assuming that the alternator is sized sufficiently to cover all these loads. Again, if there's a size problem with the alternator, it's going to attempt to feed all these loads, and whatever it can't do is going to come from the battery, and it will register as a discharge. And by the way, that if your alternator is substantially weak for the load you're running, that added current coming from the battery to make up for what the alternator is not doing, if it's a prolonged, now you're going to add more stress to these connections and the ammeter, and that too is going to overstress factory connections that were not designed for that kind of current. Okay, some suggestions on modifying your original Chrysler charging system if you want to retain the function and purpose of the ammeter, yet still harden the system to cover additional loads. This is one way to go about it. This is based pretty much on what they called the fleet bypass. Some of the police cars and taxis that Chrysler built in the early 70s, after they figured out that radios and lights were burning up all these bulkhead connectors and such, ammeters and such. They would bypass bulkhead connection terminals altogether with a rubber grommet in the firewall and a straight run from the engine harness, from the engine side into the passenger compartment, straight to the ammeter. The existing ammeter leads that were taped up into the dash harness were instructed to be cut off and taped, and these added a little bit larger wires. I think they were like maybe 10 gauge or something from the factory on the fleet bypass. Would bypass the bulkhead altogether. They would also use an 80 amp or a shunted, an internally shunted ammeter, so it can handle some more current. So what I do these days on these cars to maintain a correctly functioning ammeter, a safe, functionally operating ammeter, upsize some wiring here, bypass the bulkhead, go right straight to the ammeter with the leads from the engine compartment. I will not necessarily tap my added loads right at the alternator stud. I will find a place on the firewall to either do a stud mount, or in this case I have a 50 amp resettable circuit breaker mounted on the firewall. The charge circuit comes and goes to one side of that and then on into the ammeter. Power is then for my added accessories is actually taped off of that, or it's tapped off that stud. I'm running my MSD off of that. I'm running some headlight upgrade relays off of that and some circuit breakers for that. Fuel pumps. I'm running an electric fuel pump. The relay, the power supply for that pump comes off that stud. And there's a trunk mounted amplifier. An 8-gauge wire running back to the trunk is on the other side of the circuit breaker. The breaker is designed to trip if there's a problem with that wire to that amplifier. All of these loads are all consuming their power from the alternator on the alternator side of the ammeter. No impact whatsoever to the existing circuit or charge circuit. My ammeter still registers as it should, only charging current. This, by the way, this wire here was the original 12 gauge run over to the bulkhead number 18 in the cavity. And you just remove it and you can add it to the ammeter like this. It just makes for a parallel run basically from the splice one to the ammeter stud. And this is where the factory loads get its power. So all of this is the same. Interior lights, ignition system all get its original power sources, again coming off of splice one without an impact on any other part of the circuit. That about covers it for that. Let's have a look at some ammeters and some potential issues at the ammeter and ammeter connectors that can happen if you are not placing your loads correctly on this system. Ammeters are very misunderstood in this hobby, and a lot of people don't want to learn them, and they'll just bypass them or do a voltmeter conversion on them, which is fine. It'll still work. Let's take a look at some Chrysler ammeters from this time period. One of the most misunderstood instruments, factory equipment on these cars, even today. It's a pretty simple device, really. Simple brass bar, some magnets. Current flows in one side, out the other. The electrical current through the bus, the central part of the bus. There's a magnet in there as well, causes that needle to move. Pretty simple. Internally, it's just a bus bar there. There's nothing to burn out, there's nothing to open up. It would take 100+ amps to get that to open up through this device, to cause this thing to open or burn out, as some people like to say. The issues that some people experience, again, normally are caused by misplaced loads. These things are only designed to monitor charging and discharging current in and out of the battery, nothing else. There shouldn't be any loads. It's commonly referred to as a full load ammeter. Some people think that the load, the entire vehicle load, is registered on this meter. It's not. If it is, something's wrong. As we indicated a minute ago on the diagrams, there should be very little charging going on at the battery. But there have been issues, again, caused by either abuse at the connections or misplaced loads, too much current for what it was designed for. Most of these gauges will mount into a pot metal cluster frame and they will be insulated by a fiber board insulator. On each side of the cluster frame, there's two. It's sandwiched in here with one set of nuts, enough pressure to keep the thing in place and to keep it from not moving around. The hole, by the way, most of these cluster frames are a square hole. I don't know if you can see the pattern on there or not, but there's a square pattern of white paint from the inside of this cluster. There are tabs that fit into the end of these insulators to make sure that those studs are in the center of the square hole and they're not touching the frame. Should something happen to this fiber insulator with the notches on it, maybe it overheats somehow, goes away, and allows that to shift a little bit, now you've got an issue with a short to the frame. As long as the insulators are in good shape, they haven't overheated, shouldn't be an issue, shouldn't be a cause of an issue. The first nut is what secures the ammeter to the cluster frame. The second nut is what secures the electrical connection, the ring terminal, to the stud. You pretty much double nut the electrical connection to the stud. You don't wrench this down tight to get a good tight connection onto the stud, or excuse me, onto the ammeter mounting. Sometimes when you remove and replace these nuts, you need to use 2 wrenches. They're 3/8 inch. Sometimes they're on tight, they're locked down tight. If you attempt to remove it without a double and you bring both nuts to twist, you could put a twisting force on this stud. That can cause damage to the bus. In this case, it's very clearly that this one was removed at one point, trying to get it to unscrew with the upper nut, and it twisted the entire stud around. Now you've destroyed the connection between the stud head and the bus. Now you have resistance here. And under normal conditions, adding resistance to that connection there, the stud head to bus, generates heat. Even under normal current loads, battery charging loads. The fiber board here is designed to withstand some heat, but there's a point where it's not going to withstand heat and it's going to burn away, as this one did. This I classify as a result of abuse. It's not a design flaw. The other side looks pristine. If it was a design flaw of some kind, I would expect to see something like that on this side as well. What can you do about that stud to bus resistance? A lot of people solder the studs onto the bus. Something like this doesn't take much to do. Takes a few minutes. You need to be a little careful about the heat you create on this bus. There are some ammeters that have a plastic insulator between that has been riveted onto that bus. If you get this too hot, you're going to be melting plastic parts. To avoid that, you can drill out the rivets and replace them. When I do it, I normally just clamp on some pliers or something on this side to act as a heat sink to try to keep the heat away from the plastic. I've been able to solder these without having to take them all apart and not burned up anything. These are used ammeters, by the way, and it's very clearly this one is pristine. There's no sign of heat. There's no insulator damage. This guy lived its life in a car somewhere without failing. Here's one that shows a little discoloring on this side, which would indicate that there was some heat here at one point, but not enough to burn the insulator. And there's likely some resistance there on an ammeter like this. I would probably solder that head to the bus again and put it back into service. We already looked at that one. Now, I mentioned earlier about the fleet bypass and the fleet ammeter. This is an 80 amp ammeter, like a 72 standard cluster, B body of some kind, probably a cop car or something. As you'll see, that this is the same movement basically as what we were just looking at. These would have been scaled at about 30 or 40 amp swings one way or the other, but it's the exact same movement that's in this one. What is different is there's a shunt under the head here. I don't know if you can see it in the camera. Can't see my, see if I can get an angle to it. There's a shunt between here. The shunt will basically, since this is the same movement that we're dealing with these ones, and let's say that this is like a 40 amp swing one way or the other, to get 80, we shunt half of that current through across there. So their idea there is they can add some devices. They also bypassed the bulkhead when they did this. And it would absorb some added loads at the battery. You're never going to get all those radio and light installers to get away from the battery. But this will register those loads. Again, not what the ammeter is trying to be for. Again, not what the ammeter is designed to do. Should only show charging. You only want to see what's going on with the battery. A voltmeter. A lot of guys want to talk about putting voltmeters on here. Or what they do, a conversion. Remove the ammeter, put a voltmeter in its place, and they're good with that. You can monitor voltage. You can tell when it's charging, when it's not charging, but that's about it. An ammeter will display, if you know what you're looking at, an ammeter, abnormal charge readings can tell you quite a bit, as long as you don't have loads on the battery. If you have a cell in the battery that's failing, it usually shows up as an abnormal charged current. That's what, if you're watching your gauges and you see this, it's not centered, and you see charging going on, and it shouldn't be, I'd get the battery looked at. If it's discharging when you're driving down the road, your alternator is not keeping up with your loads. Again, if it's factory stuff, or if you have your loads on the alternator side of the ammeter, then something's changed with the alternator. The alternator no longer keeps up with your charging. So get the alternator checked out before you get left on the side of the road. That's the purpose of the ammeter. They don't spontaneously combust for no reason whatsoever.